Okay, somebody sent me this question from the sample final. This is number 2. You might or might not have exactly the same question, um, but this is one of the potential question 2s that you could get. Okay, so here we have an incomplete graph of a polynomial function, and we're given the function and this incomplete graph. It's like a little snapshot of part of the graph, and all of these numbers down here just tell us that this goes from 0 to 3 with a scale of half. So this is 1/2, 1, 1.5, 2, 2.5, and from -10 down here to 10 at a scale of 1. And then we're asked to find all the zeros of the function, and without a graphing utility, draw or complete the graph of the function. All we have to do for this is realize that they've given us one of the zeros here, right? They show us crossing the x-axis at 2.5. What that means for us is that 2.5, since 2.5 is a 0, the binomial x minus 2.5 will divide this polynomial, okay? So all we have to do is do the long division, and we can make that the function smaller, right? This is f of x here, right? Here's just the function right here. That's where I got that from. That's f of x, and I'm dividing it by x minus 2.5. And I just go through the polynomial long division of the whole thing, right? And it ends up going in without remainder this many times. So this function is going to be equal to x minus 2.5 times whatever's up here, okay, which I've written right here. F of x is equal to this binomial times this quadrinomial now. The cool thing is now this quadrinomial is factorable by grouping, okay? I'm not sure if we actually did that in the class, but it's definitely, this kind of factoring is definitely a prereq for this class. The first thing I did actually before I factored by grouping was just I recognized that all of these coefficients have a 2 in it, so I pulled this 2 out front, okay, and just made this a little bit easier to factor by reducing it. So I grouped the first 2 terms and the second 2 terms. I pulled out an x squared from these 2 and a 2 from this, and then I've got x minus 6 here. So now I've taken my polynomial function and I've rewritten it as 4 factors of 2, this binomial, and this binomial. Okay. What that does for us now is that it's pretty easy to find the zeros with the zero product property. Okay. I just want to find where the y is 0 for this function, right? That's why I put a 0 instead of the f of x. And then I'm just going to use the zero product property. 2 can never be 0, so I don't have to worry about that. This binomial can be 0 if x is 2.5. This binomial can be 0 if x is 6. This binomial can be 0, but notice it ends up becoming an imaginary number, right? Only if I plug in plus or minus I times the square root of 2. Okay. Now, so those are all our zeros for the functions. I think that's the first part of the question. All right, find all the zeros for the function. There's the 2.5. Here's one of the complex roots. Here's the other one. And then there's 6. Okay. Now all we have left is the graphing part. So we're going to take all this information we've got and get an idea of the graph. Remember, you don't actually have to graph it. You've got a multiple choice between like 4 different graphs. So you just need to have a good sense of what's going on. Okay, so first thing, we have 2 real zeros. The 2 real zeros are 2.5 and 6. So we know it's not going to cross or approach the x-axis in any other place but 2.5 and 6. So we can automatically cross off any graphs that don't cross or touch the x-axis in those places. Next, I'm thinking of the end behavior, right? This was one of the big skills on Con, is the end behavior of functions. And I know that if I have, I'm just looking at the lead coefficient to figure out the end behavior of a polynomial. And the first thing I look at is this exponent. Because the exponent's even, I know I'm going to have weird stuff can happen in the middle, but the ends are going to look like a parabola. It's going to either go, both ends are going to go up, or both ends are going to go down. Okay. Now I can look at the coefficient of 2. Since this is positive, right, that tells me that I'm going to have this situation where both ends go up. As x goes to infinity, both in the negative and positive direction, the y value is going to shoot out to positive infinity. So my graph should have end behavior that looks like this. And then does the function cross at the zeros? Remember, in order to figure out whether, sometimes a graph will come down and touch the x-axis and produce a zero, but not cross there. In that particular case, what happens is one of the factors is doubled, and this is not the actual function. But if the function was like 2 times x minus 2 minus 5, 2.5 times this binomial times this binomial times this binomial again, we would have that the graph would cross here, but would not cross here. And that's because these factors change sign as it gets close to 2.5, right? It's going to change from one sign to another as it passes through the x-axis. And since there's only one factor here, that negative will produce a sign change in the function. Whereas if there's 2 of those factors, if there's doubling of the factors, or even any even number, like if there's 4 of them, I can't think of very many examples I've seen with 4 identical factors, but if there were 4 identical factors, the sign wouldn't change, because if this is negative before, as you're approaching 6 from the low side and it's negative, this one's also negative, so it stays positive. And then as they cross 6 on over to the other side, they both become positive, staying the same positive sign. So what we can say is that because this isn't the function, right? There is no second x minus 6. So we know that we're going to get a sign change or a crossing of the graph. The y value is going to go from positive to negative at both 2.5 and 6. Okay, so the graph must look something like this. Now, you see I've got the end behavior going on here that I talked about. It's heading off to infinity. It's crossing the zeros at both 2.5 and 6. It does this. This is probably a little bit more perfect parabolic shape than it needs to be. It can do all kinds of weird things, like it can squiggle up here right before it crosses 2.5, or it can squiggle down here. But what you need to have is the right end behavior, right? And you need to have the right places where it crosses 0. You need to have the right zeros and know that it crosses at both of these places. Okay. But there's lots of variations on what this graph could look like. But only one of the options of the 4 will, have all those 3 things going for it. So I hope that helps clear question 2 up a little bit.